Hi, I'm Alan Reiner, and today I wanted to share with you this elaborate mess of rushed engineering that I just barely pulled off for Halloween this year. It includes a LiDAR rangefinder, a pressure plate, a motorcycle horn, and a whole bunch of wood, electronics, and 3D printed parts. It took me like 3 weeks of late night engineering and neglecting my family, but the end result was pretty cool, so I wanted to document it and share it with you all. Okay, Leah, you ready for Daddy's special thing? What do you see? Do you want that full-size candy bar? What if it's a trap? Do you think it's a trap? Maybe you should just take it.
Oh, we got potential customers. Great. You're spoiling the surprise.
So before we get to the meat of this project, I should probably explain why you're about to see a whole bunch of janky engineering. You see, I've always been a math and software guy. I've always done AI, cryptography, software development. Everything I've done has always been code. There's nothing physical that I could use to explain to my grandmother what the heck it is that I do. So sometime last summer, I saw a couple videos from Stuff Made Here. If you haven't seen it before, you need to check it out. The guy who does it pulls off these inhuman feats of engineering and makes really entertaining videos about them. And the thing about these videos is he really makes it look like fun. And I realized I could be having fun making things, but I have no electronics experience. I mean, when I started this, I didn't even know what the red and black wire were or how to pronounce the word soldering. So I got on Amazon and I ordered the Elegoo Mega 2560 electronic starter kit, and this was like the best investment ever. It comes with dozens of sensors and input-output devices and a PDF full of lessons on all of them. You start from basically just wiring an LED with a battery, and by even halfway through it, you start to appreciate how you can just buy electronics components online and hook them all up together with a microcontroller to do cool things. By the way, that was not a paid advertisement for Elegoo. I'm just really impressed with their electronics kit. So what is the punchline of this story? It's really that you're about to see a lot of bad electronics and engineering in this video. And it's because I learned most of this stuff like a month before I even tried to use it for this project. And then I was time crunched to get it done before Halloween. So I wouldn't use this video as a how-to for anything. This is really just for me to document my experience putting this stuff together, and I think what I built was pretty cool, and I think my family had a lot of fun watching me struggle through it. So I would be sitting right here with a bowl of candy, and I would tell trick-or-treaters when they came up, you know, here's some regular candy. If you want a full-size candy bar, you can go over there, but it's kind of risky. And of course, when they look up and they see the shifting lights, they are obviously immediately intrigued. So they approach slowly. You'll see that it has a LiDAR rangefinder on the front of it, which detects your distance from it and then slowly makes the question mark less random until you actually get up to it and it becomes solid question mark with the message, is it a trap? And there's this beautiful bowl with a full-size candy bar in it. Obviously you can see over here lots of wires. That wasn't really visible last night. The curtain was a little more closed. So when they go in and they grab the candy bar, there's a pressure sensor under here. Motorcycle horn, spider drop, red eyes. And then the whole thing resets completely on its own. And by completely on its own, I mean, it has some quirks. But overall, it does actually work. It unspools to the right length, so it's ready for the next drop. I'll show us in a bit how wildly complex that string unspooling became. This did end up being quite a huge mess of wires. Since I'm relatively new to electronics, I know that I have lots of room for improvement here. But, you know, it works. Over here's the motorcycle horn. I got the quietest one I could, but it was still crazy loud, so I had to wrap it with self-fusing tape and padding so that it would dampen the noise a little bit. It was definitely still loud enough to cause kids to jump, but without causing a heart attack. Of course, I tested this mostly without the spider, and then it frequently got stuck. One of the legs would get stuck on the string, and so I had to sit here and babysit it and make sure every time it went back up, the legs were not getting stuck, and which would prevent it from dropping. Here's the bowl that I created with the pressure plate that holds the candy bar, and I love this thing. I got this large, oversized, and especially suspicious bowl on Amazon, and I was really going for that like Indiana Jones style feel. I especially like it because that hinge switch has a really satisfying click to it, the kind that makes it abundantly clear to the trick-or-treater that they did something and something is about to happen. This thing turned out so well, I imagine it's gonna be part of like every Halloween for years to come. So here's the spider drop box with the spider still attached. You can see the contraption I made here where I tried to do the door retraction and spider lift as a single mechanical motion. So he's attached to the string, which is attached through a loop on the door. And that goes over here to these motors. I'll have a little bit about why I've got 2 motors and my engagement ring and a whole bunch of strings. But that's another story. The key, I guess, personal innovation here is that as long as the spider is lighter than the door, when everything is deployed and the spider's down and the door is down, pulling up on this motor should lift the spider first until it gets to here, and then any more that you pull will pull on the door and pull that up. And overall it worked pretty well. I was pretty happy with that. Down here it gets a little funny, and that's because I have this little solenoid latch right here, which is used for holding the door up. You can see it. It's just a latch like you might have on a door. And I designed this originally without a whole ton of foresight, knowing, you know, this thing is powered and it can kind of work, but it's probably not very strong. I completely underestimated how not strong it was. You can see I even put the wiring in to run it up to the microcontroller to try to trigger it, but it never worked. I mean, the thing barely has enough power to pull the latch up, to pull the latch open when it's not even under any pressure, but when it's holding the weight of the door, there's not even a chance. So I had to get out my modeling tools. Fusion 360, I made this really cool 3D printed holder for a servo. And a servo is really just a small little motor, and its only job is it can swing an arm, you know, from 0 to 180 degrees. And in this case, the only thing it does is it just swings that arm open and it kicks the latch to drop it. Seemed kind of excessive to build this whole structure just to trigger that latch, but it worked perfectly. The actual design for this part was super simple once I had the caliper. I was able to measure the servo and measure everything, and this whole box, I mean, this is basically just a box with a couple cuts. Just put the box in the 3D modeling software, cut out this box, cut out this box, and then cut out the hole for the servo to fit into. Actually, that explanation of how easy it is in Fusion 360 would be a lot better if I just showed you how easy it is in Fusion 360. Here's a quick demo of it. I love how crisp the motion is. Anyone who's got experience building things like this probably is wondering, hey Alan, why did you not use aluminum extrusion for this? And I'll tell you, it's because I did not know about it. I cannot wait to tear this thing down and switch to using aluminum extrusion. I have a whole bunch of it now. You can put it together. This is actually something my son put together. These little fasteners. It's these aluminum rods with fasteners for putting them together. You can even do hinges and doors and stuff like that. It's not super cheap, but I mean, it's ideal for this. So the key thing here with the electronics was down here I had the power supply. I need the Arduino and well, in this case it's actually a Seeduino. Same thing, microcontroller requires 5 volts, but the motors need more than that. So that's what this is. This is called a DC motor driver. This is pretty common in electronics, where basically the wires coming out of the motor are very raw. Like you need to pulse them or you need to do funky things with them, and you don't really want to put all that logic on your microcontroller or it may not be feasible. So you get one of these things, you plug your motors into it, plug your high voltage power supply up here, and then you attach your microcontroller to it, to these other pins. And then it gives you a really simple interface where basically you can just put in your code, spin the motor clockwise at a given speed or spin it counterclockwise at a given speed. Pretty simple. And actually it can run 2 motors at once, which turned out well because I ended up with 2 motors. I'll get into that in a bit. The wiring got messy because in addition to needing everything to be hooked up and managed automatically, I needed some remote switches. So this is a forward and reverse for the motors to pull the string up or down manually. I also have a manual drop switch, which I just pulled from an old computer. Nothing's powered right now, but I can just click that and it will trigger the same logic as if, in fact, it even uses the same pin as was used by the pressure plate. So it's not here, I've disconnected it, but I had 2 wires here that went in that were connected to the pressure plate and that box. One last problem I had that I wanted to share was you can see all these wires running up to the microcontroller. They're all actually relatively long wires, and whenever you look up tutorials or guides for any devices and sensors, they typically use really short wires. You know, if you look up something like this hinge switch right here, it's all it does is it really completes a circuit, and the microcontroller can detect when something goes from 0 volts to 5 volts. The problem is that these really long wires basically act as antennas, and they just pick up random interference from, I don't know, the cosmos or wherever, things from around your house. And so sometimes I'd just be sitting here and it would just trigger on its own. It would just, one time it actually had the motorcycle horn hooked up and I was just sitting at my desk and the whole thing just went off. So the solution here is that you have to strengthen the baseline signal so that it doesn't accidentally trigger like that. And that's what all these little resistors are here for. I had to learn how to create what's called a pull-up resistor and make it strong enough to overcome any kind of that interference. This is the box and faceplate that was behind the pressure plate, and I think this was the most fun part of the project for me, but probably also contributed the least to the overall effect, just because it was dwarfed by everything else that was going on. But it was fun, and I think I'm going to try to use it again in a future year. At the top, you've got the LiDAR rangefinder, which is used to detect the distance from as the person is approaching. And then below it is an 8x8 LED matrix, which I was able to program with the microcontroller to display a question mark with variable levels of randomness. And then below that is a text display, which can display up to 2 lines of text, 16 characters long. I had some ideas for what to do with that, but at the end, I couldn't even count on kids being able to read it or that anyone would even notice it amidst everything else going on. So it basically just displayed, is it a trap, question mark, and that was all it did. And finally, I needed something to hold it all together. So I tediously measured every single one of these things and made this 3D printed faceplate for it, which unfortunately I had to print like 12 times. But it did force me to learn all the tolerances of my 3D printer and how to correct for them. When it was finally all assembled, I programmed it to have this shifting question mark, depending on the distance measured by the LiDAR rangefinder. When no one was in front of it or when the person was really far away, it would just appear totally random. But as they got closer, it would start to solidify until it was just a completely solid question mark, hopefully adding to the intrigue that probably no one noticed. All right, let's finally talk about this elephant in the room I've been foreshadowing for this whole video. In between spider drops, I need to lift the spider up and then subsequently create slack so that when the door opens, he drops at the right height. If you had asked me what I thought would take the most time when I had started this project, it definitely would not have been unspooling a string. I mean, come on, how hard can it be to just roll the motor backwards to create the slack for the next drop? Simple enough, right? But alas, this ended up being the bane of my existence for like 3 weeks and partially responsible for why I was so time crunched at the end, because I could just not get this to work. Let me show you why. Here's one of the first tries of the system with only 1 motor, and everything seemed to work great. Success! But then, this is how it looked every other time I tried it. Hey, what's going on here? Bad motor. Okay, maybe that was just a fluke. Let's try it again. Okay, maybe we just need to go slower. Surely that'll work. Nope. I tried faster, I tried slower, I tried different string, I tried bigger string, I tried big rope, although it didn't fit. Nothing I did fixed this problem. So what was the problem? Here's my theory. The string is a little bit fuzzy, a little bit like a soft Velcro. When the motor pulls it up and retracts the spider and the door, it effectively stretches that string, and then it wraps it around the spool in contact with other string that is stretched. When you start to unspool that string, it loses its tension and then grips to all the other string around it. The most obvious solution for this is to simply add a weight to the slack string, which will pull down the string, overcoming the force of those threads grabbing onto each other. The problem with this, though, is that we need a lot of slack, and whatever weight we add to it is going to hit the bottom of the box before we finished unspooling. So it really only solves half the problem. My next best idea was to add this extra spool and motor that had a rubber grippy coating around it, and it would spin really fast while the string is unspooling, hopefully adding just enough grip that it would pull the string along with it. However, at the very beginning of unspooling, there's actually very little contact between the string and that spool. And even where it does contact, the string just isn't heavy enough to create any significant force against the spool, and the spool just spins freely under it. However, if I combine both these ideas, then they complement each other's weaknesses. The weighted ring will pull down and get the initial slack going, and by the time it reaches the bottom, it's created enough slack that kind of wraps around the second spool, and the spinning of that spool will then generate enough tension to finish creating slack. By the way, that last string that goes from the ring to the bottom of the frame is really just there to prevent the ring from getting sucked into the spool when it's pulling the spider up. Look, I know this is some major over-engineering nonsense, but you know what? The nonsense worked. I did not have it fail a single time after I put this in place. There's about 800 other things I would love to share about this project, but I think that about wraps it up nicely for you guys to get an idea of everything I went through to get this thing to work. So this video was more about my adventure learning electronics and just coming up with this crazy idea and barely pulling it off for Halloween. But I'm hoping to make more videos about a whole variety of topics, including especially 3D printing, and I want to have a series on AI educational materials. And of course, I want to work on some other projects that not only take into account electronics, but also artificial intelligence. I'd love to do some stuff with computer vision, see what cool stuff I can make with that. If any of that stuff sounds interesting, please hit that subscribe button and stay up to date on the stuff that I'm doing.